Bismillahirrahmanirrahim. In this tutorial, I am going to solve parallel circuits. Parallel circuits are also known as current divider circuits. As I told you earlier, voltage divider or series circuits divides voltage across each series connected element. In current divider or parallel circuits, current across each resistor is different, and there are again two methods of solving parallel circuit. The first method is with the help of simple Ohm's law. The second method is current divider method. In this method is going to discuss in the some other video. Now I am going to discuss solving a series circuit solving a parallel circuit with the help of Ohm's law. So let's get started. This is the first circuit I am going to discuss. This is a parallel circuit. It has a current source of 200 milliampere, two resistors R1 and R2 of equal value. The total resistance, which is calculated with the help of this formula, the total resistance of the parallel circuit is calculated with the help of this formula. 1 upon RT is equal to 1 upon R1 plus 1 upon R2, etc. I calculated RT, which is equal to 500 ohm. The next step is to calculate the total voltage, that is voltage across these two nodes. This is the voltage I am going to evaluate. V is equal to IR, very simple, and I is 200 milliampere and RT is 500 ohm. After substituting, we get the value of voltage, which is equal to 100 volts. Now with the help of RT and I, we get the total voltage of this parallel circuit. The next step is to calculate current across each resistor, that is current across R1 and current across R2. Since both resistors have equal value, so same current will flow in these two resistors. So let's calculate. IR1 is equal to V upon R1. So 100 divided by 1K. So IR1 is equal to 0.1 ampere or 100 milliampere. So what is the value of IR1, which is also equal to IR2 and equal to 100 milliampere. Very simple. Another circuit with two resistors, both are of different values. R1 is 1 kilo ohm and R2 is 100 ohm, and the current source is 200 milliampere. Again, with the help of the same steps, we will calculate voltage of this node and this node, the potential across this node. V is equal to IR, and again the total resistance is calculated with the help of RT. 1 upon RT is equal to 1 upon R1 plus 1 upon R2, and I calculated RT is equal to 91 ohm. Substitute 200 milliampere multiply by 91 ohm, and it is equal to 18.2 volt. So the voltage of this parallel circuit is 18.2 volt. The next step is to calculate current flowing through R1, which is IR1 and IR2. So IR1 is equal to V upon R1. V is calculated as 18.2 divided by 90, so 1 kilo ohm, 1k. So IR1 is equal to 18.2 milliampere. So this is here 18.2 milliampere is the current. Similarly, and here R2, which is equal to 100 ohm. Again, this is R2, and it is calculated as 180 milli. Here 180 milliampere. Here is another example with 3 resistors, a current source of 10 milliamperes, and 3 resistors R1, which is equal to 700 ohms, R2, which is equal to 200 ohms, and R3, which is equal to 100 ohms. I calculated total resistance, which is equal to 62.5 ohm. The second step is to calculate the voltage of this node and this node. So with the help of Ohm's law, V is equal to IR, which is equal to 10 milli into 62.5, which is equal to 0.625 volts. So the potential drop across here is 0.625 volts. Current flowing through this resistor and this resistor and this resistor. So this is IR1, which is equal to V upon R1. Substitute values. V is equal to 0.62 divided by 700 ohm, and it is calculated as 0.8 milliampere. In the same way, calculate current flowing through R2, which is equal to 200 ohm, 3 milliamperes. Similarly, calculate current flowing through R3. IR3 is equal to V upon R3. Substitute values 0.62 divided by 100, and it is calculated as 6 milliamperes. Circuit with a voltage source of 5 volts and again 3 resistors with equal resistance of 62.5 ohm. You can see we don't need to evaluate total resistance value or equivalent resistance value, because we just simply need to calculate currents across current flowing through each resistor, that is IR1, which is equal to V upon R1. We know about the voltage of this node and R1, and don't need to evaluate the total current flowing through this circuit. So let's substitute values. And it is equal to 7 milliampere. IR2 is equal to 25 milliampere. Similarly, IR3 this is now for IR3, and it is equal to 50 milliampere. So it is easy to solve. Goodbye for now.